Welcome to SciSense, where we unwrap scientific research, because science should not be a puzzle.
Mike, I am so excited to talk about this breakthrough today. Scientists just figured out how to destroy forever chemicals, PFAS, at room temperature using lithium metal. This is huge.
Wait, forever chemicals? That sounds ominous. Are we talking about something from a superhero movie?
I wish it were fiction, but no. PFAS are real chemicals that have been dubbed forever chemicals because they basically never break down in the environment. We're talking thousands of years. They're in drinking water. They're in your blood. They're literally everywhere.
That's terrifying. What makes them so indestructible?
It all comes down to one of the strongest bonds in chemistry, the carbon-fluorine bond. Think of it like this. If chemical bonds were chains, most are like regular bike locks. The carbon-fluorine bond is like a titanium vault door. It takes an enormous amount of energy to break.
So how did we end up with these things everywhere? Did someone think this was a good idea?
Well, yes, actually. That strength is exactly why we made them. PFAS are used in non-stick pans, waterproof clothing, food packaging, firefighting foam, anywhere you want something that resists water, oil, and heat. The problem is, once they're out in the environment, they don't break down.
Okay, so we've got indestructible chemicals everywhere. How does lithium come to the rescue?
This is where it gets really cool. The researchers built an electrochemical cell. Think of it like a specialized battery that generates lithium metal right where they need it. Lithium is incredibly reactive, especially with fluorine. It's like lithium looks at those supposedly unbreakable CF bonds and says, "Hold my beer."
But wait, isn't lithium dangerous? I've seen videos of lithium exploding in water.
You're absolutely right to be concerned. Lithium metal is super reactive. It catches fire in air and explodes in water. But here's the genius part. They generate it inside the electrochemical cell, right where it's needed. It appears, grabs those fluorine atoms from the PFAS, and the reaction happens in a controlled environment. No explosions required.
That's actually brilliant. So what happens to the PFAS when lithium attacks it?
The lithium rips the fluorine atoms right off the carbon chain. The fluorine becomes fluoride ions, which is actually the same stuff in your toothpaste. Totally harmless. And the carbon chain that's left behind? Just simple hydrocarbons. They essentially dismantle these forever chemicals into completely harmless pieces.
And they can do this at room temperature? I feel like breaking the strongest bond in chemistry should require, like, a volcano or something.
Right? That's what makes this so groundbreaking. Current methods for destroying PFAS require temperatures over 1,000 degrees Celsius or extreme pressures. This works at room temperature and normal pressure. That's a game changer for actually implementing this at water treatment plants.
How effective is it? Like, are we talking it kind of works or really works?
Over 99% destruction. They tested it on PFOA and PFOS, two of the most problematic forever chemicals, and achieved over 99% defluorination. That means they removed over 99% of the fluorine atoms, effectively destroying the chemicals.
That's incredible. So could this actually clean up contaminated water supplies?
That's the hope. The fact that it works under normal conditions means water treatment facilities could potentially add these electrochemical cells without building some massive high-temperature reactor. Military bases, which have huge PFAS problems from firefighting foam, could treat contamination on site.
What's the catch? There's always a catch.
Fair question. Right now, this is lab-scale research. Scaling up to treat millions of gallons of water is a different challenge. You need electricity to run the electrochemical cells. Lithium isn't free, and real-world contaminated water is messy. It's not just PFAS in a clean solution.
Still, it sounds like a huge step forward.
Absolutely. For decades, we've been creating these chemicals that don't break down, and now we're finding them everywhere. Drinking water, wildlife, even in penguins in Antarctica. Having a practical way to actually destroy them, not just filter them out and create more concentrated waste, is massive.
You mentioned 12,000 different PFAS compounds earlier. Does this work on all of them?
They tested it on several different types, and it worked across the board, which is really promising. The key is that they all have those carbon-fluorine bonds, and lithium is really good at breaking those specifically. But yeah, more testing on different compounds would be needed.
I'm just imagining some chemist in a lab finally cracking the code on forever chemicals and doing a victory dance.
I mean, honestly, they should. This is the kind of chemistry breakthrough that could genuinely help millions of people. When science fiction becomes science fact and we find a way to undo our environmental mistakes, that's worth celebrating.
So what happens next? How long until this could actually be cleaning up water?
That's always the million-dollar question with breakthrough research. They've proven the concept works brilliantly in the lab. Next steps would be scaling up, testing with real contaminated water, making the process cost-effective, and eventually pilot programs at treatment facilities. We're probably talking years, not months, but the foundation is there.
Well, here's hoping this moves fast. Forever chemicals sound like something we should have been dealing with yesterday.
Couldn't agree more. And this gives me hope that even our most persistent pollution problems might have solutions if we get creative enough with chemistry.
Thanks for listening to SciSense. Share it with a friend. See you next time.